Tuition Mobile, quality e-learning experience on the go.
Nutrient cycling in nature. Carbon cycle is the circulation of carbon through ecosystem. The sources of carbon are respiration, burning of organic matter, decay, volcanic eruption. Carbon is important in nature because it is used by plants during photosynthesis in allotropic or atomic forms like diamond, graphite, etc., which are precious to man. In carbon cycle, carbon atoms from carbon dioxide are incorporated into organic compounds formed by green plants during photosynthesis. These compounds are eventually oxidized during respiration by plants which made them, or by herbivores, carnivores, man, and saprophytes, which are organisms that live on dead organic matter, thus releasing carbon dioxide for further photosynthesis. Carbon dioxide can be added into the atmosphere either artificially by burning or naturally through volcanic eruption and decay of organic matter. Water cycle, as you can see on the screen. Water cycle involves evaporation and condensation. After rain, water is seen on the surface of the soil, some of which enter the lakes, streams, rivers, or even high seas and oceans through underground movement. Plants release water during respiration and evaporation. Animals live on water for drinking and digestion of food. This they later release through urination and defecation, etc. In dry seasons, part of the water evaporates and on becoming heavy in the clouds, condenses and falls as rain again. The importance of water can be seen in its ability to be used by plants and animals for survival. It aids digestion and excretion. Rain helps in purifying a very polluted atmosphere, and water bodies act as sources of food supply to man, for example, the prawn, the fishes, seaweeds, etc. Oxygen cycle. Oxygen is 20% of the gas contained in the atmosphere. The quantity of oxygen utilized during cellular respiration balances up with equal amount of carbon dioxide used up during photosynthesis. Burning of fossil fuels uses up oxygen. Aquatic organisms are very much affected with shortage of dissolved oxygen through pollution, either oil or other organic types. In order to check this, a considerable amount of oxygen is added to aid degradation. This is called biochemical oxygen demand, the BOD. We should note that alkaline pyrogalol or pyrogallic acid is used in experiments involving absorption of oxygen. On the right hand side of the screen is the oxygen cycle. Decomposition in nature. Decomposers are grouped into two, the micro decomposers and the macro decomposers. Micro decomposers include all saprophytic organisms, that's organisms that live on dead organic matter, such as the putrefying bacteria, the fungi, and protozoa, while the macro decomposers include small animals such as insects, rodents, earthworms, and woodlice. The end products of the composition of organic matter are ammonia, urea, and carbon dioxide. Other end products are hydrogen sulfide broken down by thiobacillus. We have the sulfur dioxide and water vapor. The role of decomposers. The role of decomposers are: they make it possible for organic matter which would have accumulated in the environment to be recycled through decomposition. Plants are able to use up their products for growth in order to produce food for consumption.